boy, Patrick. While our heroes are away, we will keep evil at bay. Ha! Ah!
Huh?
What is it, trusted sidekick? Man Ray!
Manta rays are ocean giants. The two species of manta ray are the oceanic giant manta and the coastal reef manta. Giant manta rays, or Manta birostris, can reach lengths of 25 feet from wingtip to wingtip, while their smaller coastal cousins tend towards lengths of up to 17 feet. The giant manta ray belongs to kingdom Animalia, phylum Chordata, class Chondrichthyes. The clade Chondrichthyes encompasses the rays and skates, sharks, and chimeras. Giant mantas are filter feeders, eating phytoplankton and algae floating through the water. They are camouflaged, having black on their dorsal side and white on their ventral side, and this allows the ray to blend in with the light shining through the water from below and the dark appearance of the water from the surface. They are too large to be hunted by most ocean predators, so they have inherited this coloration from their smaller ancestors. Giant mantas migrate thousands of miles to aggregate in large swarms to feed and mate. They follow plankton as they move through the warm water currents and consume them by rolling through the water. The rays will follow these areas of high primary productivity to warm, subtropical, tropical, and temperate waters across the world. The giant manta ray is currently listed as vulnerable on the IUCN Red List and rapidly nearing endangered. The giant rays are protected in many regions of the world, but have been overfished in small coastal communities where people rely on them for food and alternative medicine. While rays in some areas have seen little damage to populations, other communities have nearly been wiped out.
One interesting research article that was published recently concerned the mass gathering of Manta birostris off the Yucatan Peninsula. The study sought to understand what makes habitats suitable for the rays. Additionally, the research was conducted to analyze spatial and seasonal distribution of mantas and how they respond to different environmental factors. The time frame was 2006 to 2011, with data collected from May to September. Specifically, the north and northeast coast of the Yucatan Peninsula was the focus of the study. This is a zone of upwelling, high primary productivity, and the boundaries of the Tiburon Ballena Biosphere Reserve, created to preserve populations of whale sharks that live in the area. The rays were primarily observed using scientific surveys, with some being seen incidentally through whale shark surveys. The environmental factors that were measured included sea surface temperature, concentration of chlorophyll A, primary productivity, depth, and both distance to the coast and slope. Maximum entropy modeling was used to describe the suitability of habitats in ideal conditions for the rays. Percentages of factor contributions were used to analyze which of the environmental factors was most influential to the manta's behavior of aggregation. In total, 5 Maxent models were produced, 1 model per month. In total, 528 manta rays were observed. A majority of these sightings were in the reserve. The study found that primary productivity, which is the rate of production of organic compounds by photosynthetic or chemosynthetic autotrophs, was the most important factor of manta ray distribution during May to August. In September, distance to shore was the most influential variable. Overall, the probability of mantas being present is highest when sea surface temperature is greater than 27 degrees Celsius, primary productivity is higher, water is shallow, and the location is not far from shore.
The changing distribution that was exhibited in this study is characteristic of manta ray behavior around the world. The cause of distribution change in the region studied was seasonal changes in upwelling. The Yucatan Current creates upwelling, which therefore provides mantas with a constant source of phytoplankton, which is abundant in upwelling zones. The suitability of the Biosphere Reserve is good news, but an increasing amount of mantas were observed in an outside zone as the study progressed. If these trends continue, it may be necessary to change management strategies of mantas in the Yucatan region. Manta rays are very important to ocean ecosystems. When phytoplankton are left without predation, they grow into red tide blooms, which wreak havoc on ocean ecosystems. Manta rays reduce these red tides and maintain the natural balance of the ocean. Therefore, these magnificent creatures are necessary for the survival of the world's oceans.